These are your video notes on writing exponentials and graphing exponentials. I combined both of these standards into one video, A9C and A9D. So let's start with the exponential growth and decay formula. Y equals A times B to the X. Now be mindful that this formula is not on your formula chart. So it's really important that you remember this. It's fairly simple, especially since A is your starting value and it comes at the beginning. So like over here, I notice there's nothing in front of this. I would put a 1 here, because you can multiply by 1 without changing the number. This means that the y-intercept is 1. Here, the y-intercept is 2. Here, the y-intercept is 3. The A term represents your starting value. In this problem, I notice that it starts with 1 bacteria. B is usually found in parentheses, but what's important to know is that it's the base on the exponent. And the exponent is however many times it's going to grow or decay. And then the last thing is what B represents. B is your growth or decay factor. This, I like to say, is what happens to it, or what you end up having, what you have in the end. Rates would be what happens to it. I'm combining words here. Alright. And this is going to make more sense here in a bit. So if you triple the number of bacteria each day, what do you end up having each day? Well, if you triple it, you're going to end up having times 3 each day. It happens to be what happens to it as well, but in this case, this would be our rate and our factor. So our factor goes in the B position, and then X would be however many days something was occurring. So let's take a look at this, and that maybe it'll help you make more sense of it. If my factor is less than 1, then it is decay. So for instance, 1/3. That would be decay. Now if I type this into my calculator, I can pull points pretty easily. So I have 1 times 1/3 to the X. Oh, I forgot to close my parentheses. And then I can look at my graph here, and you'll notice that it's headed down. So that is decay. If I need my table of points, I can just go into second table. I like to start with -2, -1, and then move into my positives. 0, 1, which of course is my y-intercept. It was also my A value. And then 1, 1/3, 2, 1/9. And if I plot this, I can't do -2, 9, but I can do -1, 3, 0, 1, 1, 1/3, 2, 1/9. So this is going to be getting closer and closer and closer to the asymptote, which is this invisible line, this invisible barrier that this graph will never touch or cross. And if you look at our y's here, you'll notice that these numbers they just become bigger fractions. So tiny, 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 tiny numbers, but never 0. We're past the 0, so never negative. This invisible barrier that I put in a highlighter crosses the y-axis at 0. This is how you write the asymptote. My domain, because this thing goes on forever and ever and ever, looking at my x-axis would be all real numbers. My range, 0 is the lowest it will go, but it will not touch the 0. You can also write this as y is greater than 0. This example would be growth, because my B term is bigger than 1. You can also see it on the graph if you type it in. You'll notice that the graph is headed upward, so that's growth. If you look at your table, you can go ahead and start plotting your points. -2, 0.22222, -1, 0.66666, 0, 2, which of course is our y-intercept. Makes sense because it's our a value, our starting point. And then 1, 6. I'm not even going to write 218 because it's not going to fit on this graph. So -2 and then tiny decimal, -1, slightly bigger decimal, 0, 2, 1, 6. 1, 2, 3, 4, 5, 6. Exponential growth. My domain again is all real numbers. It's not going to touch the 0, and actually it's not going to touch the 0 because that is where our asymptote is. Our asymptote is what I highlighted here. Crosses the y-axis at 0, and all my y's are bigger than that. So you could just write it as y's are bigger than 0. You don't want to say they're equal to because it doesn't touch the 0 on the y. So now we're going to be identifying which statements are true, which statements are false, and we're going to make sure we say what is, or how to make it true if it's false. So this one says the initial amount of the function is 3. Well, the initial amount is a, and it is 3. The function represents decay only if it's less than 1, the b term. Here's the b term, and it is less than 1. The rate, remember rate is what happens to it. And what goes into the formula is what we have. So if you have 0.95, we could change this to a percent. You have 95%. That means you lost your rate. If you take 95% from 100%, it will tell you what you lost. So this is false. Our rate is 5%. Our factor is 95%. So what goes in here was either subtracted from the whole value, 3, or added to the whole value of 3. This says the growth or decay factor is 0.95. Yes, it is 0.95. Factor is what goes in here. The y-intercept is 0.95. Well, a is my y-intercept. So this is false. My y-intercept is 0, 3. I know that the asymptote can't be x equals 0 because this graph, you can put it in your y equals, looks just like the other ones. Not sure I typed that in right, but it is going downward. It is very wide. I'm going to zoom out. There we go. So clearly my asymptote still crosses the y-axis. So my y equals 0 is where my asymptote is. The graph of the function is decreasing. Yes, it was decreasing. So now you're going to take these notes and you're going to apply them to some situations in your quiz. Make sure you hit submit in your modules.